Nuclear energy has been a global hot topic for almost a century now, evoking both fascination and fear among people. However, in the specific context of the United Kingdom, nuclear energy plays a rather special role in the development of the country, marked by triumphs and challenges. As the nation strives to transition toward more powerful energy sources, the $46 billion project, Hinkley Point C nuclear power station, stands as an exceptionally pivotal program, capturing both the positive and negative offerings of nuclear energy. Today, we'll delve into how the British have used up their nuclear resources, the benefits and dangers associated with the upcoming grand project, the disposal of radioactive waste, the cost, and the roadblocks it faces along the way. The United Kingdom's foray into nuclear energy began with the establishment of the Calder Hall nuclear power station in 1956, which became the world's first nuclear power station to deliver electricity in commercial magnitude. This point is marked as a groundbreaking milestone in its industrial history, with upcoming decades witnessing the installation of various new nuclear power plants across the nation, which was solely driven by the desire for the UK's energy security and economic growth. Many advanced nuclear power plants were built in the 20th century, which cost from $30 million to $2.4 billion between 1966 and 1998. In the 21st century, a debate unfolded, with many people protesting against the nuclear projects, suggesting that there's no need to further develop nuclear plants given the global prices, generation capacity, and the environmental contamination that comes with it. However, the government's Energy White Paper stated that at some point in the future, new nuclear build might be necessary if the government is to meet their carbon targets. Over the years, the British government has endeavoured to address the shortcomings of earlier nuclear operations, while advancing towards a cleaner and more sustainable energy landscape. As a result, initiatives such as the Clean Up Programme, which was outlined in the Nuclear Decommissioning Authority's or NDA strategy, are proposed to underscore the nation's commitment to clean up nuclear sites and tackle other related environmental hazards. Moreover, agencies like the Office for Nuclear Regulation, or ONR, establish a stringent regulatory framework that aims to uphold safety standards and transparency within the nuclear industry. If the UK is this adamant about continuing the nuclear programs that it has established various governing bodies, then there must be some high reward, right? Well, turns out that there is. Nuclear energy offers a multitude of advantages, including low greenhouse gas emissions, high energy density, and operational reliability. It's also a great low-carbon alternative to fossil fuels, as nuclear power plays a pivotal role in mitigating climate change and diversifying the energy portfolio. Moreover, nuclear reactors boast extended operational lifespans, ensuring a consistent supply of electricity to meet societal demands, as nuclear energy alone generates around 1/5 of the country's electricity. Not only that, the upcoming Hinkley Point C project will yield 3.2 gigawatts of energy, which will be enough to satiate 7% of the entire country's energy requirements. UK government policy is to have a wide mix of energy supplies, which involves using nuclear alongside solar, wind, and gas energy. The reason why nuclear energy is so crucial here is because these power plants produce electricity 24 hours a day, regardless of the weather conditions. They also don't require a daily supply of new fuel to operate, unlike gas, coal, and other biomass plants. Not to mention that they generate electricity without ever emitting harmful gases like carbon dioxide and methane. However, the benefits of nuclear energy come with many risks associated with improper management and catastrophic accidents. For instance, the Chernobyl and Fukushima disasters serve as humbling reminders of the potential consequences of nuclear accidents. One of the most severe consequences of such detrimental events is radioactive contamination, which can lead to long-term health problems. What's truly concerning is that radioactive waste is still getting produced regularly, even without any misconduct from the management. Radioactive waste encompasses a spectrum of materials, ranging from spent nuclear fuel to decommissioned reactor components. and each one of those poses unique challenges in terms of containment. Apart from that, radioactive material is now a part of almost every field of professionalism. For instance, radioactive materials are used to sterilize equipment, help diagnose and treat medical illnesses, and gamma rays are used to test the quality of welds or the thickness of products like paper, the operation of active nuclear-powered submarines, and the deconstruction of the retired ones. Nuclear fusion technology also helps develop new radiotherapy treatments and test novel solid materials for encapsulating liquid radioactive wastes. This existing waste is currently being stored above ground at more than 30 sites around the UK. These surface stores can be considered safe for a long time, but they require continuous protection and monitoring to keep them secure and in good condition, because the waste remains radioactive for hundreds of thousands of years. To flawlessly conduct this, there is internal consensus that geological disposal is the safest and most secure way to manage higher activity waste for the long term. The Geological Disposal Facility, or GDF, ensures that the responsibility of continually protecting this waste is not passed on to future generations. The implementation of a GDF makes it mandatory to have rigorous stakeholder engagement, constant scientific assessment, and ethical considerations regarding intergenerational equity. Furthermore, the Geological Disposal Facility understands that public perception plays a pivotal role in shaping the media surrounding radioactive waste management, so it aims to win their trust through righteous transparency and collective decision-making. Hinkley Point C is part of the new generation of power plants, which are way more cleaner and efficient than the old and rusty ones. It originally had an estimated $20 billion of costs, but because of delays, that has touched the $46 billion mark. This project was meant to be finalized by the year 2020, but because of one of the giant financial funders withdrew from the project was slowed down. Not to mention that the COVID-19 pandemic also negatively impacted the pace and progress of the program by disruptions in the supply chain, increased inflation, and removal of workers from work sites. As a result of this, the project is now pushed back around 8 to 11 years and will be operational somewhere around 2029. This almost decade-long delay in construction timelines and cost overruns has prompted scrutiny from industry analysts and policymakers who have raised questions about the construction, feasibility, and long-term viability of nuclear power as a cornerstone of the UK's energy strategy. That's not all. Energy technologies are also evolving in the current era, and there's a shift in the market dynamics which can pose formidable challenges to the nuclear industry's traditional paradigm. New renewable energy sources are globally emerging and have surpassed nuclear in terms of energy storage and grid flexibility, which means that the competitive industries are actively on the lookout for an opportunity to fully replace nuclear energy. Hinkley Point C nuclear power station is truly an ambitious project and will be a game changer for the United Kingdom if everything goes well according to plan from now onwards. The nation's government will not be worried about the costs as long as the power plant fulfills its desired purpose. But the questions remain. Is the UK doing the right thing by investing all this money in the same energy source? So far, keeping everything in perspective, the pros outweigh the cons, and nuclear energy appears to forge a more sustainable and equitable future for the country.